I'm your instructor, Kevin Vilbig.
My name is Bea.
And we have helpers. We have Stephanie.
Hi, I'm Stephanie. I'm a librarian here. One quick note, we are recording this, so please sign in and sign the model release form. If you have to walk in front of the camera, don't duck or do something awkward, just walk past. It's a lot less distracting. Thank you.
And so a general overview of what we're going to be going over is the schedule here. Today is day one. We're going to start by doing data organization in spreadsheets and also open refine for data cleaning. And those are two kind of separate but linked lessons. If you go to this webpage, if you see it's kevin-vilbig.github.io, and then the date, and then Rutgers, which you should have a link to. There are course notes in here as well. So if you want to follow along there, if that helps you. We're also going to be using this tool, which is an Etherpad. And if you go to pad.software-carpentry.org, and then the workshop code, which is the 2018 TAC 05 TAC 16 TAC Rutgers. And if you see up here, it'll have a sort of a list of who's in this Etherpad. Go ahead and put your name in the little spot. And then we have chat. And then this is a edited text document. So this is a commonly edited text document. So we can all edit this all together. It's kind of like Google Docs, if you ever use that. Except this is meant to be more ephemeral. So another tool that we're going to use today are these sticky notes. Does anybody not have sticky notes? Okay. So we're going to use those right now. If you are logged in to the Etherpad and have your name, put a green sticky up on your computer. And if you're having trouble and need a helper to come help you, put up the pink sticky or red sticky. Close enough. All right, so it looks like we have a bunch of green stickies up. So everyone take your stickies down. And yeah, I'm going to start talking about our first lesson, which is going to be data organization in spreadsheets. So we're going to be using whatever sort of spreadsheet software you have. I use LibreOffice, but you may have Microsoft Excel or a number of other different spreadsheet software. I think most of this can even be done on Google Sheets, but there are some limitations there. So okay, so we have the first principle is like good organization of data in order to do computation on that. It's the foundation for any analysis. Most researchers have data, I'm not even just researchers, but businesses, everything has data in spreadsheets. So it's the place where research projects start. So we organize data in spreadsheets in the ways that we as humans want to work with data. But computers require that data to be organized in particular ways. In order to use these tools to make this computation more efficient, such as R, which we're going to be learning later today, we need to structure our data in the way that the computers understand. So in this lesson, you will learn good data entry practices, how to avoid common formatting mistakes, approaches for handling dates, basic quality control and data manipulation, and then how to export data from spreadsheets so we can use these other tools. So in this lesson, you will not learn about data analysis with spreadsheets. We don't do any data analysis in spreadsheets. We just do the basic data structuring so that we can do the analysis later. This is actually, like, even though this is only a short part of the workshop, most of your time will be spent doing this kind of data cleaning. This is the lab tech kind of stuff. This is there's the idea where it's like 90% of the work takes 10% of the time. This is the 10% of the work that takes 90% of the time. So the first thing that we need to do is get the data file, which I'll drop into the Etherpad. Oops. Data file. I'm going to not have the Etherpad up here on the front. I'm going to be looking at it here because everyone should have their own copy now. And so the ways you can ask if you get stuck, if you get lost, if something unexpectedly breaks, you can put up the pink sticky, or you can also ask in the Etherpad chat. And then, because the helpers, myself, and Vin will be watching that to be able to answer questions as we have time. And so it should be an Excel file. It's called survey_data_spreadsheet_messy.xls. So the first step is to open it. And so put up green stickies if you have the data file open, and put up a red sticky if, all right, everyone's good. So before we actually dive into this, we're going to share some information in the Etherpad. And the question is, how do you use spreadsheets in your work? And if you don't, that's fine. I say, what do you use spreadsheets for? And go ahead and answer that in the Etherpad.
Do you want it on the pad or in the chat?
On the pad. And you can put your name or not, it doesn't really matter. Whichever y'all like. All right, so looking at these, it seems like people use budgets to collect data, to organize, summarize, and clean data. More about budgets, which we're not doing today. We're doing ecology. And then preliminary analysis and looking at data patterns, which that's a good point, Anupam. I always try to eyeball data. Like if I download a data set that I'm looking at, I always open it up in a spreadsheet program to sort of look to find those patterns as well. That can be useful. But if you download something, we'll talk later about comma-separated values. You can even open it in just a text file. Cool. So we're going to start by talking about how to format data tables in spreadsheets. The most common mistake made is treating spreadsheet programs like they're just a lab notebook, which is relying on the context, notes in the margin, like the spatial layout of data in fields in order to convey information. So as humans, we can usually interpret these things, but computers don't view this information in the same way. And unless we can explain to the computer what every single thing means, it will not be able to see how our data fits together. Like I like to say, computers are really fast at being very stupid. They can't make inferences. They do exactly what you tell them to do. So using the power of computers, we can manage and analyze data in a much more effective and faster ways. But in order to use that power, we have to set up our data for the computer to be able to understand it. And so that's why it's important to set up well-formatted tables from the outset. It's even better before you even start entering data from your very first experiment. That data organization is the foundation of the research project. It can make it easier or harder to work with your data throughout the whole analysis. So it's worth thinking about when you're doing your data entry or setting up your experiment. You can set things up in different ways in spreadsheets, but some of these choices can limit your ability to work with the data in other programs or have your first collaborator is you 6 months from now. And so you need to think about yourself in the future. So when you're working with spreadsheets during data cleanup or analysis, it's very easy to end up with a spreadsheet that looks very different from the one you started with. In order to be able to reproduce that analysis or figure out what you did when your reviewer number 3 asks for a different analysis, you need to make sure to create a new file or tab of your spreadsheet with your cleaned or analyzed data. You don't want to modify the original data set, or you will never be able to get back to where you started. So you always sort of want to keep your original data set, even as messy and terrible as it might be, you want to keep that the same because that's keeping track of the whole process. And so the cardinal rules for using spreadsheet programs and data. Put all of your variables in columns. The thing you're measuring, like weight or temperature or a budget line item. Or like a budget number, the date of a thing, and say the notes about what that thing is, or the category of that budget item. Then put each observation in its own row, and then don't combine multiple pieces of information in one cell. Sometimes it may seem like one thing, But think if that's the only way you'll ever want to be able to use or sort that data. Leave the data raw. Don't change it. And then at the end, you want to be able to export the cleaned data to a text-based format like CSV, which is short for comma-separated values format. And this ensures that anyone can use the data, and it's actually required by most data repositories. So for instance, what we have here is we have data from a survey of small mammals. I think they're like kangaroo mice. And if you look, we have 2013 data, and then we have 2014 data, and then we have dates, which is I'm not even sure what that is right now. Which is kind of the problem that we're going to work on here in a moment. And so this data file is like how to do it all wrong. So what we're going to do first is we're going to take this data, and then we are going to describe how we would clean it up. And so each one of these is a different field assistant that collected data however they felt like it. And so in the Etherpad, let's go ahead and talk about what do you see that is wrong? What do you see that's wrong with this data based on the principles that we discussed? And also they talk about some of the steps that you would need to take in order to clean up this 2013 and 2014 tabs. And we're going to take about 10 minutes to do this. And so at about 9:15, we'll move forward. Okay, it's only been 8 minutes, but there's a lot of answers up there. And I'm going to kind of dive in to the next section now. So I was kind of looking, and you'll definitely have a lot of the right idea. Let me move this out the way. And so we're going to talk about the sort of common spreadsheet errors. The first big one is using multiple tables in the same spreadsheet, and which we saw here and also here. This confuses the computer because the computer assumes that each tab, like each sheet, is one large data table. So putting multiple smaller tables in one sheet is a big no-no, because the computer sees this as one entry record, this sort of blue line. And so you're using the same field name multiple places and drawing false associations between things. And this will make it harder for you to clean up your data. So also another thing that can be tricky is actually using multiple tabs, even using multiple tabs like this. So when you create those extra tabs, you fail to allow the computer to see connections in the data that might be there. So because you have 2013 and then 2014, even though all of this is pretty much the same data, there might be connections between things that happened in 2013 and things that happened in 2014. Like you may be able to make graphs about the average weight of one of these species of kangaroo mice. And you wouldn't be able to do that if you had it in multiple tables. So always when you're entering data and you push this plus button to add a tab, ask yourself if that's necessary or if you can get the same effect by adding another column. And one thing you can do is freeze the column headers so that they remain visible even when you have a spreadsheet with many rows, which is a really useful thing to have. So we're going to kind of start. So you notice that I made a new tab, and so it's going to be different on your program. But I think it's what, tools. And so you're going to need to look through your menus and figure out what it is. And I'll put a link to the Office, Microsoft Office, into the Etherpad. This is like a serious pro tip. It's down on line 87. And I never remember this stuff because I don't need to, because it's up there all the time. Was it window tools? And so this is one when you figure out how to set up the freeze, put up a green sticky, and if you need some help, put up the red sticky. So another mistake that is often made is not filling in a 0 when the value is actually a 0. So if you say the number of times that a rabbit is observed is 0, you don't see that rabbit in a survey, why would you bother writing in the number 0 in that column when it's mostly zeros? But there is a difference between a 0 and a blank cell in a spreadsheet. To the computer, a 0 is actually data. You actually measured a 0. A blank cell means that nothing was measured, and the computer will interpret that as an unknown or a null value. And it's fine to have null values in surveys. That's part of doing science. Sometimes you can't get a measurement. But you have to measure that. You have to communicate that it's a null value. There's another problem that can happen is using problematic null values. So instead of leaving it blank like this, you can use like -999, or I saw one in some CDC data. It was in some of the files it was negative, was it 1,111.11, and in some others it was negative 2,222.22. And so if you didn't take a look at the data, at the metadata for these CDC data tables beforehand, and went and were like, okay, now I need to get the average infant mortality in this county, or in this state. Some of the counties where the data was null, you'd end up getting like negative infant mortality rates, which doesn't make any sense. Luckily, it didn't make sense, but if in some cases, using those null values may get something that at first glance seems right, but then when you go to publish, people are like, what happened? So I'm also going to drop a link into the Etherpad that has a list of different null values that get used. And I have some recommendations. This is from, I think, Ecology and Evolution, a journal. Or Ideas in Ecology and Evolution. So these are some good rules of thumb to use with null values. So the other issue with this is using formatting to convey information. This is what our second lab tech did here. This here with these gray cell means that the measurement device wasn't calibrated. As far as it comes to like doing calculation on this data, that doesn't mean anything to the computer. It just doesn't show up for doing any type of statistical calculation. So the way to fix that is you create a new field to encode which data needs to be excluded. So we go to sheet 4, which I'm going to rename here to cleaned data. And so we'd want to add a new field here, was like, call it scale calibrated. Or call it whatever makes sense to you. The thing here says calibrated, but I'm doing scale calibrated because I don't mind long variable names. And something that I even did here, something you generally want to avoid when you're going to be working in R or SQL or any other programming languages is avoid putting spaces in your variable names, because that can break things in fun and exciting ways. Because like I said, computers are very fast at being very stupid, so sometimes it sees the space and just blows their mind. And so another issue is to use formatting to make the data sheet look pretty, like merging cells, which I don't know if we have any of that here. I don't think we do, which is good. But like, don't merge cells. That can be good if you're using it to print. But since we're not, this is not something that we're making a spreadsheet to print and hand out at a board meeting or something, right? We're doing some actual data analysis here. And so we're formatting the data so the computer can work on it. Don't do any of that. It breaks everything. Also, another issue is placing comments or units in cells. So we can see here, it's like we have 33 grams or 132 scale not calibrated. That isn't seen as a number anymore. That's seen as like an alphanumeric string. So instead of that being like the computer encoded 33, that's seen as 33G, which you can't like multiply that with 50. Another issue we see on plot 4 is entering more than one piece of information in a cell, which in this column D, where it has species and sex in the same column there. And we already talked a little bit about field names. And generally, you can use underscores instead of spaces. So if this is this way of doing it is called camel case, where you capitalize every word in a multi-word. But you can also use underscores if that makes more sense to you, or if that's what your PI or boss wants, I guess. I don't really care. Underscores are harder to type, and so I usually use the camel case because it's faster. Also, avoid using any special characters. I mean, emojis these days, I mean, in some programming languages you could use emojis in variable names, and who knows what we're going to see 10 years from now. But at this point, keep it to sort of normal English alphanumerics, because these won't break anything. They've been doing this for 30 years, 40 years at this point. Also, don't put metadata into your data table. Don't add a legend to the top or to the side, because it'll be the same sort of issues as that you'll find if you're doing this sort of thing with the multiple tables in one row. If you want to have metadata to explain, you put it in a separate file. That was one of the things about that CDC data set, is they did have like a README file in there that said, these are what all the null values mean, this is that, this is that. And so you want to have your the metadata that explains what's going on in the table, if it needs extra explanation, in a separate file, or a separate tab. But I kind of think of each tab in these as a separate file anyway. So we kind of have the, and that, I mean, that's it. That's the stuff. So we're also going to talk about dates as data, which is fun. So this is what we're going to use this dates tab for. So dates in spreadsheets are stored in a single column. While this may seem like the most natural way to record dates, it is actually not the best practice. And spreadsheet applications will display dates in a seemingly correct way to a human observer, but how it actually handles and stores the dates might be a problem. In particular, remember that functions are valid for a given spreadsheet program, are usually guaranteed to only be compatible within the same family of products. If you will later need to export the data and need to conserve the timestamps, you're better off handling them using one of these solutions discussed below. Additionally, Excel can automatically turn things that aren't dates into dates. So if you're avoiding the date format overall, it's easier to sort of identify those issues. And so what we're going to do here is we're going to extract information from this date, from these date columns, using some built-in functions. So we're going to use year. And so I kind of broke this down a little more than I needed to. So now is the date and time right now. Today is the date today. And then I subtracted today from now. Because today is actually 05, 16, 18, and then 0, 100 hours, basically. And then pulled out the hour from C17, and the minute and the second from this derived date, this derived time today. So we've kind of done this exercise to see how we can break this data out from these dates. So what we recommend is to go ahead and store year, month, day explicitly in your data in separate columns, or as year and day of year in separate columns. So Excel can't do dates before 1899, December 31st, 1899. And we'll leave those completely untouched. So if you're mixing old historical data from before and after that date, Excel will only translate the post-1900 dates into its internal format, thus resulting in mixed data. And if you're working from historic data, be extremely careful with your dates. Excel also uses a second date system. That's the 1904 date system. And that's the default on Macs. And so, and the way the date information is actually stored in Excel is as like the number of days since 1900. So like these dates here, I mean, it's showing up in this human readable date, but it's actually like 47,000 something, and it's actually that integer number, which is ridiculous. but that's sort of why we have this recommendation, to avoid all of that nonsense. Which back when when spreadsheets were first developed, it probably made a lot of sense to have a single, 16-bit is 65,535? But have basically like a single variable that could hold that data, a single integer variable to hold the date. That made sense, and it's probably only still that way because of backwards compatibility. It's actually more like 41,000, not 47,000. What's kind of weird is that you can, because Excel stores dates as numbers, so let's say let's do A3 plus 45. So you can add days numerically that way, and it will automatically sort of coerce that output formatting into a date. So what we're going to do here, what we're going to do next is we're going to export this XLS, this tab for dates, into a comma-separated variables and look at it in a text editor like Notepad or TextEdit or whatever. So you'll see File, Export, and you should be able to select CSV. I'm not exactly sure how it works in Excel. And so if you're really into dates, I dropped a link to the Wikipedia article for ISO 8601, which is the International Standards Organization for date exchange formats. This is how things are done online a lot, and is one way to do it, and is a way where there will probably be a lot of libraries built in. But in order to avoid that, avoid messing with all of those libraries right now, that's why we recommend doing a simple year, month, day in separate columns. Okay. And it's going to be different for everybody. Probably different for everybody from what I'm doing. So you're going to do File, Save As. And then I saved it as dates.csv. And I will replace that file. And mine does a warning, only the active sheet was saved. And then where I saved that, I saved it in my downloads folder. And then open that up with my Notepad. Okay, so now what we're going to actually do is the data cleaning process. We're kind of at about, we're almost done with this lesson. So what we're actually going to do is take all of the data in 2013 and 2014. You don't need to worry about dates anymore. That was sort of pulled out to do these exercises about dates. And then we're going to be dropping all of this into cleaned data. We're going to do this for, I don't really know how long. Probably like, because it's 10 now, so probably like a half hour, because lunch is at 12:30. So maybe like half hour, 45 minutes, and include breaks in there. And once you get where you're kind of happy with it, put up a green sticky. And otherwise, I'm going to be kind of doing it myself, and then we'll be available to answer questions, and the helpers will be around. So put up a red sticky if you get lost anywhere and need some help. Let's clean this data using all these principles that we just discussed. And also, a pro tip: if you're having to do things manually, there's probably an easier way to do it, and you may want to ask questions. So if you're going through and like deleting lines and doing a lot of doing that stuff manually, there is an easier way to do it. And so if you do get stuck, ask for help. I'll kind of. This is kind of where I'm at now, and kind of what. One quick tip is when you get to 2014, I don't know if this works in Excel, but it works for me. So you put in like plot 1. Did I just delete the end of plot 1? Yes. So you put in that 2. And say you go to drag that, and it ends up automatically incrementing. So the 2, and then for me, I hold down Control and drag, and it doesn't automatically increment.
Oh, so I can just paste them all.
So for how to divide this species with the underscores in it. So I copied over the data from 2014, really just, and of course it's going super slow right now for some reason. So I copied over the data from 2014. It's not liking my font changes. So I copied this over. And so then we select this. Hold on a second. I'm going to fix that. It's going slow because it does not like my font change. So the first thing you want to do is take this numeric weight data and move it over. And so that was Shift and then select and then drag. So select the first cell and then Shift click on the bottom cell and then drag that, click and drag that selection. So now we have this, and you can see there's a pretty clear pattern here. There's species and sex with an underscore in between it. And so there's a thing somewhere. What's it called again? Text to columns. And so your dialog box might look a little bit different, but the thing you need to think about is the separator options. And so we're going to separate these by an underscore. And you can look at the preview. And so even when you get chaos from somebody, you can clean it up. And the reason why you have to make sure to move things out of the way is that operation will nuke what's ever in the next field. So make sure to clean that up. Text to columns. It'll be up in format maybe. I'm not sure what it is. Huh? Tools.
It's a separate thing that shows up on Excel.
Okay. Cool.
Is there some split there for all of them?
So something you may want to pay attention to when you're cleaning the data is the 2014 field season data from plot 3 will copy over as 2015.
Really sure.
So another sort of tip, we have with the gram listed in here. This is another place where that text to columns can work. And this definitely falls under the dirty tricks category. So text to columns, and then you set your separator as G. I mean, it's probably a good idea. That's what we recommend as best practice. Especially because remember the dates for which plot, was it plot 3? And the 2014 tab, they were actually all set, which I'll click back over here, as 2015 dates. And so,
And the 1978 is still fine as 1978.
that is historical data from 1978, yep. And so if you look at, which, starting here at this plot, oh, looks like I did the thing wrong. Oh, it's my plot 3. I just went really easy here. So here you can see that I did the formula. But then below that, I just did put in 2014 and control dragged. There's probably a cooler way to do that, but that was easy. Where's the link that I put? I put a link in the Etherpad.
Yeah, I saw that. The best option is using the word blank. The second one.
It's not actually the word blank. It is actually to leave the cell blank, because that's a null value everywhere. Whether using R, Python, SQL, that is a null value. And so that's the most compatible way to do it.
Just keep it as it is.
Just leave it blank. It's difficult for, it's a little bit more difficult for like eyeballing it, like if you're just looking at it, because is it blank or is it a space or what? But for the actually doing the computation, that is the best thing to do. Yeah. So since most people are here, this is something that's kind of extra that we're not going to need, but it's really, really good. Because remember the thing that, and I know I said 10:45, but I'm just going to start now because I think most everybody's here. And so we have Excel. What it's good for and what it's really good for is data entry. It's really, like, once you have this sort of data table set up, it's really quick to just 10 key a whole mess of data into Excel. And so Excel has some tools built in to help make that easier. And those tools are data validation, quality assurance tools, so that even your freshman lab class might be able to produce something worth publishing, which is pretty cool. So we're going to show this quality assurance and data validation, and we're going to use this plot. And I don't remember where it is here up here, but it's somewhere. Is it validity in here? Yeah. So mine's validity. Yours should be data validation. It'll be under data. And the things to think about are this allow criteria. And so you can allow all values. For the plot, we only have whole numbers. And we know that the valid range is going to be between 1 and 24. And how do we know that? Because my notes say so. But actually, this is from a study, and there were 24 different plots where they were looking at these kangaroo mice. And so now, when you go to enter this data, hopefully that worked. It says invalid value. And so I think it's really cool that you can add this input message. So when a cell is selected, so title, valid plot IDs, (1 through 24), acceptable. So now whenever you have that cell selected, it pops up a little flag next to it that tells you exactly what needs to go into there, so that anyone who's doing data entry will know what these cells are for. And this is the stuff that Excel is super good for, that spreadsheet software is super good for. So you can also add validity and allow a list of values. And so like instead of having these things be like coded as like DM, OT, whatever, you can actually put in, and I'm going to have to crib here, Dipodotamus spectabilis. I butchered it, but yeah. And then actually have that full data in there. And then I'm going to kind of cheat here and just do what DO, OT, NA, DM, DS. I think that's all of them. I may have just knocked one out, but that's fine. So when you add that list, it adds a drop-down menu. And make sure that before you do any of this stuff, that you save a quality control, because I probably killed that value. Which what was that? Plot 3, 2014. No, that was actually blank, so we're good. So before you do any of these operations, make sure to save your original file with any formulas and a name indicating that it is the original data. And you want to create a separate file and ensure your data is stored as values and not as formulas, because formulas will refer to other cells, and you may be moving cells around during this data cleaning process. And another good thing to do is go ahead and create, like when you're doing this stuff, you want to create a README document. And say things like, today, what is the date today? The 16th. So 5, 16, 18 moved 2013 and 2014 data into data table. And then say that's all you do today, and then, other day, move, set up data validation. And then save this with your file as README. And so generally, in order to keep your stuff organized, you want to keep all of your projects and all of your sort of projects that you're working on in separate directories. And so you'd have README, and mine's kind of dumped into my downloads folder. So what you'd have in that file would be the dates.csv README, and then the survey data spreadsheet. But then, we'd save this as survey data spreadsheet cleaned. And I'd say exported. Data, and even go from Excel, from messy Excel into clean data table, set up data validation, exported to clean CSV. And keep a log of what you do so that other people looking at your files can be like, and you in 6 months can look at it and say, what did I do? And so you can see I opened this CSV up in, this is actually another spreadsheet, piece of spreadsheet software that I have. And because it's a CSV, it imports into anything. And that's why CSVs are so good. And honestly, the only reason Excel doesn't do everything in CSVs is because of Microsoft corporate anti-competitive philosophy. The 3 E's of Microsoft: embrace, extend, extinguish. And so this is what a cleaned, standard format, flat data table will look like that can be imported into anything, which I think is pretty cool.